a little bit misty.
Red button for record.
I'm here from University of Memphis, Associate Professor, I believe, of Computer Science. He's going to talk to us about their research that he's involved in with deep web.
Thank you very much. And first things first, thanks for inviting me. It's a very smooth drive from Memphis to here. I really enjoy the ride. I'm David Lin. My Chinese name is King Yip. And given these Chinese names, no wonder I'm teaching Memphis. So this is actually going with a lot of our students. Joe is actually one of our group in our group right now, and some of them are graduate students, some of them already graduated. But this is sort of a combination of work. So how many of you have heard of the term deep web before? Let me get a sense of how many of you have heard of deep web. Right, not many. That's good. So we'll give a little bit more on the motivation side of things. So probably the web nowadays is basically part of everybody's life, right? Whenever you need to know something, like the first thing you do is what? Google, right? Google has become a word, not a noun anymore, right? So we can see that the web is a very huge information source, right? They are estimated people who make estimation of how large the web actually is. They basically crop part of the web and then do some extrapolation, so on and so forth. They estimate last year there were estimations there are 11 billion pages on the web. Now, and Google at the beginning of the year they claimed that they already indexed 9+ billion pages. I'm talking about billions, not billions. So there's really a lot of pages. So now the big question is, how do you find the information that you need? Right? That's the perpetual questions that you ask. There's so many things out there. When I try to find something, it's like finding a needle in a haystack. So there are tons of search engines out there. As I say, Google is now a word basically. Like you Google for something, and basically from a user standpoint, what you really do is just submitting keywords, right? You say I want to find a word about, say, pizza, right? So I type in the word pizza, and then they return URL of pages that contain certain keywords. Now, if I look, instead from the user point of view, I'm looking from the system point of view, then what happens? Basically, all of these search engines have something called a crawler, automatic program that actually goes on the web, right? Download all the pages, download the URLs, and then extract all the critical information, right? Usually like the titles, usually like what words they're using, so on and so forth, and then index it. And then when a user asks for a query, let's say I want to find all information about pizza, maybe pizza in Jonesboro. So I type pizza Jonesboro. Then basically what they do is that they look at all the documents that they have, and they find which of them contain the word pizza and Jonesboro. Right? Now, of course, there are some actually behind the scene work out there that they have various different algorithms to figure out if there's tons of pages which are the most relevant, so on and so forth. But if you're familiar with Google technology, you know that they have something like PageRank and all these other fancy tools that help them to do just. So feel free to ask any questions along the talk, and feel free to get any pizza. I was worried that I'm the only thing between you and lunch. Turned out I'm not, so that makes me feel better. Okay, so now, but the search engine has their own limitations. Now, how many of you have tried to find something and it turns out that it returns something that's completely irrelevant? Probably many of you have experience like that. Right? When I want to search for the programming language Java, they give us where to get the best copy, for example. Right? So relevance is an issue. Organization, right? So right now they are basically listing the things. When you search something on Google, what do you get? You get a list of URLs, right? The top 10 page, the next 10 pages, and once again they may be very, very different in terms of what kind of content they contain, right? Just so pick on the word Java. Java can mean at least 3 things, right? Which 3? Programming language, right? Coffee, and the nation, right? And the region in Southeast Asia. So at least 3, and God knows there might be a 4th and a 5th that we don't know. Right? So also another limitation is that current search engine doesn't respond very quick to new data. Now, to a large extent, this has been somewhat elevated. Probably, if we talk about the web, the sort of most important development in the last 2 years, arguably, is probably the development of something called blogs, right? Now, everybody has blogs. Right? So many search engines, for example, Google, they now have you can search the blogs, and they can have something fast response. So, to some extent, these have been somewhat elevated. Now, also another problem is that, right, the search engine can only be as smart as the query you give, right? If you like to search for me, the type David Lin, right? You will receive tons of David Lins out there. I presume I'm not the only David Lin in the world, so there may be other David Lins out there. So you don't know. If you cannot give more specific information about me, all you're going to get is a lot of jumbled information where you have to filter it yourself. But one of the most important problems, and the one that we are going to deal with in our research, is the search engine only indexes explicit URLs. Now, what do I mean? So a page can only be discovered if there is a URL referred to it. Now, probably everyone heard of the term URL, right? If your HTTP :/ all the stuff, right? So everything that is stored on the web has a URL associated with it. That is an address. Now, most of them are explicit. So your website, you have a web address, right? However, many of them are implicit, or you really didn't put it on the web. Let me see if I can fire up the web browser and show you a very quick example. So let me go to this is our university website, right? So I can search for people, right? And let's say, for the sake of, let's just type my name in it. So they will start searching, right? They will return some information about me, right? My name, my email address, right? My phone number, fax number, my office number, and who am I really, right? Now, this information are not necessarily explicitly stored. Notice that there is a URL associated with this piece of information. Right? However, it is not explicitly linked in any web page. You don't have somebody put a link in it to point to that. So a crawler, when they crawl the web, they will not discover this piece of information. And then they will not discover, say, all this information about me, for example. Now you may say, oh, Dr. Lin, you are a professor, you must have your home page and you must have all those information there. Fair enough. But there's a lot of cases where these kind of information are not available anywhere, but except in, for example, we have a lot of new students coming in, right? And for those students, they really don't have any web address, web presence. So all the information are on phone books, right? Like this white page. So you really have a lot of information that is on the web, but if you search for Google, you won't be able to search for this if I didn't put my phone number explicitly on. Right? So the point I want to make here is that there's a lot of information on the web where the search engine really doesn't have a way to extract. So, and so the limitation here is that search engine really cannot access the information until they know the search phrases, right? If you know my name, you can probably construct a URL. If you don't know, then you can't. And sometimes you don't even know how to construct the the URL is set. And list of search phrases usually change or hidden. Now, we call this part of the web where you don't really explicitly have a URL to access it, but you can access it through either search interfaces or databases. We call this the deep web. In the past, it's also been called the invisible web. Actually, when we first start our research on this topic, it's called the invisible web. Nowadays, practically everybody calls it the deep web. Now, this might sound very sort of abstract, but let me throw a couple of sort of more concrete examples. How many of you have ever actually go on to Obis or Travelocity to book for flights, right? Or hotels or everything, right? So if you go on this website, right, you have an interface, right? I want to go to Memphis on, say, December the 31st. I want a hotel room, right? So you type in all the things you want, you press the search, and they will return you all the hotels that's available in Memphis, right? So these are information that is in the deep web. That means you don't have explicit, your crawler cannot explicitly crawl for that information, but when you search through, say, Obis or Travelocity, you'll be able to get them. It is very important in a lot of fields. One thing we look at is biomedical fields. People talk about DNAs, proteins a lot, and there's a lot more and more websites who actually post these information about individual proteins to enable people to search. They're not going to have explicit web page to store to list all the proteins because there's just too much out of it, but they allow a search interface for you to search. And obviously things like phone books and archives are very natural sort of sources for the deep web, because you don't have a page listing all the phone numbers of everybody in Memphis, for example. But you have an interface saying if you type my name, you get my phone number. Now, the deep web is huge. There are once again many sort of study how big the deep web can possibly be. Back in 2000, it's probably one of the most cited numbers done by a company called Bright Planet, and since then they changed the website to Complete Planet, and I think they also developed a new company called Profusion. They sort of estimate there will be 7,500 terabytes of data. Now we are not talking about gigabytes, we're talking about terabytes. A more recent study done at the University of Illinois has suggested there's at least 300,000 websites, and it's growing very fast. There are more and more companies coming up, more and more data sources, right? So on and so forth. Now, they are not necessarily unique, by the way. Many of them may store similar data, right? You have tons of travel websites, right? They practically store the same. But even if they duplicate 3 or 4 times, there's still going to be massive amount of data out there where the web doesn't explicitly store. And the databases are hidden. They are databases, and they are hidden data repositories. So, and all of them are accessed via a web interface, just like the one we saw earlier on the phone call. So you have to access. You need my phone number. Go on the university website and type my name and search for it. Right? Can't get it the other way around. So there are already a lot of work that is done to extract information about the deep web. Right? There are some websites that actually collect invisible deep websites. Right? There are actually proprietary engines. Most of these search engines are proprietary. That means it's not open for the public. So nobody really knows what's going on inside those search engines. They might just be people actually searching. For all I know. Right? Now they have their limitations, right? If you have listed them, all you have to do are just manual browsing and searching, right? And basically, there's no good one-step program. What I want is something as convenient as Google. You type in something, you hit search, they go to search not only just the web, but the deep web, and extract all the information. So that's what we want. We want a tool that automatically maintains the database of the deep websites. they automatically store the information about the deep website. And then let's say when I try to search, when I type in David Lin, then they try to figure out which are the more likely deep website that contain information about me. Probably the biomedical database won't contain information about me, right? Hopefully some criminal records don't contain information about me, right? Hopefully, right? But information maybe about computer science professor, that's very likely to contain information about me. Then let me go there and search. And then basically, then you actually do the automatic search for the user. And one of the sort of side goal in this project is to apply a lot of what we call data mining technology. Try to do a lot of data analysis automatically, analyze large amount of data, and try to do better to help with our search process. So this is our proposed system. So this is the World Wide Web. This is the web out there, and we have basically, we can think of it as four components plus a database. We have a database that stores all the information about the deep website. For example, like the U of M phone book, like the Travelocity website, so on and so forth. And then we have four other components. So in the first step, there's once again a crawler, just like any standard search engines have a crawler. The difference is that a crawler will extract every URL and store in a database, which means that you're going to store a huge amount of information. Right? So if you're not rich enough, if you're not powerful enough, you won't be able to maintain that amount of storage. But if you only store the deep website, there's not going to be that many. So that means I can extract all the information about the crawler and then store the deep websites into the databases. Then, let's say after we build that, the first step we usually do it offline. And then after we do that, then when the query actually comes in, what we're going to do is to have a query pre-processing. So that it will actually, let's say I want to search for David Lin. Right. Now, as I say, there are many David Lins out there in the world. Right. There's a Chinese saying, if a brick falls down from the sky, you basically hit on tens of David Lins. So then what do? You actually go on the web and search for information about David Lin and use them to help to guide the search. So when you search on the web, you may say, oh, David Lin actually looks like he has some association with the University of Memphis. Right? Or David Lin, I come from Hong Kong, so maybe there's some website in Hong Kong that contain my name. So maybe those are the information I need so that I can restrict what I'm doing. So once I do that, once I finish all the pre-processing, then I'm going to go and look at the database that I'm storing. So I have, for example, information about different search engines. So based on the result of my previous step, I can figure out, David Lin is about University of Memphis, it's about Hong Kong, it's about a computer science professor, but definitely not about criminal. So I don't need to go to the jail databases, I only need to go to the U of Memphis databases, I need to go to some database about Hong Kong, I need to go to some database about computer science professors. And so we select all those search engines that we need. Then we actually go out and actually send the query to those search engines and let those search engines actually extract the information that we want. And we collect the result, post-process it, and output to a user in a very nice manner. So that's the sort of the big picture of what our system we want the whole system to do. Now for this talk, I'm going to focus on the first step, the crawling step. This is probably where we put most of our work in so far. So this is where our focus is going to be. Now, so as you mentioned, our current focus is on the crawler, right? We want to crawl the web, and then we extract the deep web database from those web pages. Now the key thing here is that we know that in order for us to be able to access the deep web, the access to be done by interface from the web page. So you always have you can always ask a query through that web page. And in order to ask a query through the web page, most of the time if you know your HTML, the thing you ask a query is done by using forms, right? So there's HTML forms. Right? So basically, I go to a web page, I look at the web page, I see if there's any form out there, right? And that can be done very easily by looking at the form tags. Right? If there's a form tag, then we look into it. If there's not a form tag, we ignore it. Now, of course, there are some cases where everything is explicitly written in code, JavaScript, so on and so forth. At this stage, we're not going to deal with that for now. And somewhere down the road, we're going to revisit the issue. And then based on, after we say, okay, this web page has a form. So this form might actually be searching for a deep website. Then we extract appropriate information about it. URL, what type of search engine it is, what type of keywords. And then, even if I have a form, doesn't mean that it must be a search. Right? On the web, there are many places where you use forms, like password, right? When on the web page, they ask you to enter stuff. There are many places they ask you to enter stuff. In addition to doing a search, you may be asked to input your username and keywords, right? You may be in a forum where you want to type something in, right? You want to type, oh, this talk is tremendous, or you want to type out this talk stinks, right? For example. So a lot of things a form can do a lot of things. But for our purpose, what we want is to know is that the form actually do a search. So it turns out we derive some very simple rules to determine whether a search form to a deep web database is really a search form to a deep web database. So we turn out, and in terms of very simple rules, already give us 90% accuracy. And typically, turns out at least up till now, when you want to do a search, your search form usually have the word search somewhere. So that is itself a very good rule of thumb. So that part isn't very difficult. Now, after doing that, as we mentioned, we want to store the information on our database. Now, at this stage, we want to be able to figure out, hey, this search engine actually search about people. That search engine actually search about information about the U of Memphis. This search engine actually search about anything about baseball. Right? Those search engines actually search about things about college football. Right? This search engine actually search about things about DNA. So we want to classify things into topics. So this enables subsequent steps to find relevant sites easily. Right? And it enable a presentation of the website into categories. So we take two major approaches here. There are two ways we can go on that. The classification-based approach and the topic-specific-based approach. We're probably going to spend more focus on the first one, and then we'll probably breeze through the second. So if we want to be more specific about the problem we are solving, we can put it in these terms. So we are given a set of deep websites. These are represented by the content of the web pages and represented by the information on how to send the query. So we got all this. Now we want to determine which subject this site belongs to. Right? We want to know whether this search engine actually search about medical stuff or we search about football stuff. Right? Now, technically, we can think of it as a text classification problem. That means given a piece of text, you tell me what subject it belongs to. Right? Right? If I get a news article about the ASU Indians, right, and then they contain the word touchdown and interception, then you probably guess it's about football, right? Right? Then probably about the ASU win over Memphis a few weeks ago. Right? So but if you contain words about George Bush and Iraq and whatever, then very likely it's something talk about politics, right? So we can treat this as a problem like this. There's nothing wrong for doing that. It turns out this may not give us very good result. We actually have a student doing the comparison right now, and initially doing it this way doesn't provide very strong result. So we have to switch gears. One thing we have tried is that we want to apply what we call a probation. Now notice that we have access to the database interface. We usually don't have access to the complete database. We usually cannot go to the website owners, hey, I want to look at your whole database, right? Usually if I ask them what they tell us, probably back off, right? If they are nice. Right? Right. And don't want to imagine what will happen if they're not nice. So you cannot say access the whole database and take a look. So that is out of the question. However, since it is a publicly search engine, that doesn't stop us to actually issue some queries to that search engine. Right? So one thing we can do is this. Let's say I want to see whether something is about sports and something is about politics. Then what we do is that we first decide on certain words that actually talk about sports. For example, let me restrict it further. Let's say talk about football. Right? To talk about football, usually you have the word what? Touchdown, interception, right? Many other words, quarterback, right? Defensive back, so on and so forth, right? So these are the words that we talk about football, right? Now, if you talk about politics, maybe you want to talk about, say, the U.S. politics, then words like president, Bush, Clinton, senator, representative, these are the words that are probably going to talk about politics, right? So once we get those words, we're going to send these words to the search engine to search. So we're going to send the word interception to search, see if they actually return something. We send the word, say, quarterback to the search engine, see whether that search engine returns something. Right? So if you send the word quarterback in the Memphis phone book, they're probably not going to return anything. But so far, I haven't heard of anybody whose last name is quarterback. Maybe somewhere down the road. Right? Now, on the other hand, if you send words like, say, for example, Bush, Clinton, or other things in certain search engine, you may actually get some interesting results. So based on how much we return, how many things are returned, we determine which category it belongs to. Right? If you, let's say, you send the word interception to a search engine on, say, NFL.com, you're probably going to return a lot of things because we probably talk about a lot of games where interception is something. Right? If you send the word, say, senator into a search engine about U.S. Senate, you probably will get a lot of things out of it. Now, and in the original approach, which is basically done we borrow this approach. This is not the original approach, is not by us. If I remember correctly, it's by somebody at Columbia University, although I may be wrong. It's basically, if you know exactly how many things are being returned, you can actually have some definition of some metric to determine which area really does it belong to. Now, one problem we face here is that we really don't know exactly how many things are returned. Sometimes they tell you, sometimes they don't. And even if they tell you, different search engines tell you in different ways. And to find out the right way is going to be very difficult. So our modification is to use this approach. Use the relative size of the search result page. So first I'm going to send what we call a nonsense query. For example, we search for this string. Right? And I will bet 99 out of 100 times it's not going to return anything. If you search this thing or whatever search engine. Then you send the keywords to search. So when you compare the result of the two, so each time when you send something to search, it's going to return a page, right? Right. If there's nothing found, the page return will say no matching, no match, right? If there's actually something returned, it will actually list what is being returned. So if you compare the size of these two web pages, it already gives you a good idea whether something is in that, something related to that keyword is in the database. Now, of course, we have